Dad, what's the future gonna look like?
Thank you, Cyrus. Thank you, Up Partners. Yes, thank you for investing. Finally, they invested. Thank you very much for my team who's here supporting our show. We've got our airplane down a couple hangars down. Please come check it out. Okay, so I'm Robert Rose, CEO, Reliable Robotics. We're building autonomous aircraft systems. I absolutely love airplanes. I love being in airplanes. I love being around airplanes. Even, I am a pilot and I get to fly occasionally, but even commercial flights, I don't know about all of you, but I get a little excited when I get on board, even if I'm sitting in the far back of the plane, as long as I can see out the window, I'm excited. This is the view coming back home from a recent trip. The sunset over the Pacific coast at Bodega Bay. I was glued. My neck got sore because I was so glued looking out the window. It was absolutely beautiful. I feel like this is as close as I'm ever going to get to space. And you get to see a little bit of the curvature of the Earth, and you get a little bit of perspective about how wonderful and absolutely beautiful planet Earth is. I think aviation is the most wonderful invention that has ever been created by human beings. And I want to explain a little bit why. Aviation has given us all unprecedented connectivity. This is the Pan Am 707. This is the aircraft that shrunk the world. This is what connected nations, connected regions, allowed people to experience other cultures and see each other in ways that really were unimaginable before. Aviation has also given us absolutely unprecedented peace and prosperity before. Anybody know what this is? This is the signing of the North Atlantic Treaty. You know, think about trying to sign a document like that when you have to travel around by boat. It's just unthinkable. And you look at what we have today, recent agreements, the Abraham Accords, JCPOA, other agreements like that. You know, those happen because human beings are able to see each other in person and directly exchange their ideas. Aviation has also enabled tremendous amount of commerce and connectivity between nations and other regions in the world. This is one of the first aircraft that actually Pan Am also flew that connected the Pacific Islands. But I think aviation can be so much more than it is today. And this is what gets me really excited, and I want to talk to you about this. You know, there's a lot of new aviation systems here that people are developing. If we can get more aircraft into the sky, we get more of what I was just describing and new things that I think will be even harder to imagine. But aviation is held back. Aviation is held back because it requires people to operate these big, heavy machines. And we simply don't have the labor to be able to operate aviation at the scale we need to for it to realize its full promise. And so that's why we started Reliable Robotics. We started back in 2017, and we set out first to automate this vehicle, a Cessna 172. We operated it 2 years later, completely unmanned. And what's really significant here is that this was, to my knowledge, the first time a commercial company without any military or government support, other than FAA approvals, operated an aircraft like this, unmanned in civilian airspace and over a lightly populated area. We followed that up in 2023 with this flight on a Cessna Caravan. Again, this was an FAA-approved, fully autonomous, nobody on board operation. We worked very hard on this. The FAA gave us a little bit more level of rigorous review on this vehicle, but we got through, and I'm very proud of the work that we did. We're not working on getting this system certified. Well, actually, we've been working on getting this system certified for 8 years since we started the company. But now we're in the detailed lower level hardware and software qualification and testing, and you can see here a recent series of Autoland tests that we did on our new vehicle, which actually is the aircraft A20 Foxtrot Echo that's parked a few hangars down. I also want to point out the level of rigor that goes into doing something like this. This is not about building time. This is not about getting reps and sets on a system. This is about really hardcore, low-level engineering and analysis. And we challenged ourselves. Okay, it was a very impressive video. We challenged ourselves to get everything going on the very first try, and we successfully auto-landed the aircraft not on our first attempt, but actually on our very first day of flight testing. And it's because the system matched what we had designed in simulation. Was that a heckler I heard? I thought I heard somebody heckling me. So a common question I get at this point is, well, Robert, don't aircraft already fly themselves? And the answer is, it's complicated. And I want to walk you through this and why it's important that we build the system, why we started Reliable Robotics. This is what the final moments of landing a commercial jet look like. I've got this sped up so you don't have to watch the whole 4 minutes. But I want you to pay attention to all the various places where the pilot touches the instrument panel and all the various systems that they're cross-checking. I looked at the flight crew operations manual for this aircraft and went through this slowly, and I annotated all of the set items, the interfaces that the pilot has to manipulate, and the check items, the things that they have to double check. And I hope I've convinced you now that aircraft don't fly themselves. Oh, and by the way, this is the fully automated landing version. When you don't have the automated landing system enabled, there's even more set items and check items. The set items here, I've highlighted these in red. These are all the places where the pilot has to touch. The green items, these are all the things that the pilot has to monitor continuously. On top of all of that, the pilot is legally responsible for looking out the window and ensuring that they do not come anywhere near colliding with another aircraft. These are all of the radio and navigation functions that the pilot needs to be monitoring. And by the way, if anything were to go wrong, the pilot has to be an absolute expert in all of these other systems. We got to get rid of all of this. We got to make aircraft radically simpler to operate. And so that's what we're doing at Reliable. I want to walk through the functions that are involved in building an autonomous system. When an aircraft is in manual flight today, the pilot's responsible for taxi, takeoff, in-route operations like climb, descend, and landing. But even when the aircraft is in, quote, automated flight, the pilot is responsible for many different functions, including the lateral planning, vertical planning, speed planning, following standard instrument departures, arrival procedures, as well as configuring the aircraft for ILS and other RNAV, area navigation operations. While all of this is going on, the pilot has to look out the window, see and avoid hitting other aircraft, communicate. They're responsible for climate control, pressurization of the aircraft, and monitoring for errors. And when something does go wrong, there's so much here that I couldn't even fit it on the slide, but there is a 400-page, quote, quick reference handbook that the pilot needs to be an expert in managing. 1,900 pages in a flight crew operations manual the pilot needs to be familiar with. It takes thousands of hours of training to get here. Okay, so have I convinced you aircraft don't fly themselves, okay? All right, we're there. Good. Okay, why don't aircraft fly themselves? Because of the reliability challenge. We have to build autopilots that meet the standards that we expect in civilian aviation. And to give you a sense of comparison here, I'll compare aviation to automobiles, a mode of transportation many people are familiar with. I used to work at Tesla, but I'm sorry, my daily driver is a 2005 Honda Accord. And the reason I love this car is this is the most reliable automobile ever made. I'm just stating a fact. This thing it will go 500,000 miles in its lifetime. I'm confident, as long as I put gas in it, change the tires, and change the oil. 500,000 miles, a half million miles at an average of 50 miles an hour is 10,000 hours of operations, about 400 days we can expect service life for a car. But a commercial aircraft is designed to work in 1 billion hours. That means one failure is accepted in 1 billion hours of operation. That's 114 millennia. I think this can be hard for people to kind of grok what it means to have something that's like 1,000 times more reliable, orders of magnitude. So I'll express it in terms of distance. If anybody's a jogger or a runner, I'm not. So I can make it about 5 miles. Best case, I'm being very generous here. Before I have a failure, I need to stop and I need to catch my breath. Anybody, can you run 5 miles and you're good? Okay, I'm trying to make this an interactive presentation. All right, so 5 miles, one failure, that's like a car, okay? But an airplane would be like jogging to the moon and back. That's the difference here in level of reliability. So at Reliable Robotics, we're building systems that automate not only all of the function but at the level of reliability that we expect in commercial aviation. We have built systems, actuators, flight computers, radar systems that end-to-end automate an airplane through all phases of flight. And it's aircraft agnostic as well. Pictured here was our Caravan as well as our KC-135 program. This is some of the hardware. You can see this if you travel down and you visit us in the hangar down at the end. I want to talk about the radar. So detect and avoid is a key problem that needs to be solved. And nobody has yet, until us, built a radar that is certified to meet the FAA standard for detect and avoid. I actually announced this at UP.Summit 2 years ago, and I'm happy to report that we're now flight testing this unit, and we're picking up tracks. It also doubles as a long-range weather radar. This thing can see out over 100 nautical miles and can build a higher resolution 3D volumetric picture of the weather systems in front of us. Okay, so where do we go with this? What does autonomy enable? Well, there are commercial cargo customers that we're working with. And in the next couple of years, when the system is certified, hopefully 2028, we will launch commercial operations, and we will have hundreds of Caravans in the United States operating with no pilot in the cockpit, fully autonomous, no human required for safety. But in the meantime, we can sell our system to the Air Force. And I want to eliminate another misconception. Just because it's the Air Force, it doesn't mean it doesn't have to be certified. The Air Force has their own certification processes. They're just different than what the FAA expects. So going back to what aviation can be, I get really excited about what the world is going to be like when we have orders of magnitude more aircraft. And if you can go with me on this imaginary journey, I want you to think today about what is the current state of aviation. Think about how you got here, most likely by a plane, most of you probably through a commercial airport. And I'm sure many of you are familiar with what is good and bad about commercial airports. But imagine if aircraft fly themselves, we can double the number of aircraft that we have operating today in the United States. And think about how that reduces the friction involved in transportation. Think about what that means to delays or cancellations or the number of places that we can access. Probably has an impact on cost as well. But keep going with me here. Instead of doubling, imagine that we have 10 times the number of aircraft that we have operating today in the United States and what this might enable. Clearly, we're going to get to a lot more airports. We're probably also going to have much smaller aircraft. The economics wouldn't drive us towards 300-person planes. We might have 50 or 20 or even smaller aircraft. There may be personal autonomous aircraft that can take you where you want to go. We have 5,000 airports today available for public use in the United States, and we can unlock them with autonomous aircraft. But now what if we had 100 aircraft? Or 100 times more aircraft than we do today. Airports probably look very different, and the way that we live and we work and we travel in this nation and the world is going to look very, very different. And that's a future that I'm really excited about. And thank you for letting me share this with you.
The future is gonna be awesome.